separation of a ternary mixture. In this lab, you will take a mixture of iodine, cobalt, chloride, hexahydrate, and sand, put it together in a beaker, and then using their physical properties, separate them to their isolated parts in separate containers. This lab is important in terms of understanding the physical properties of matter. In this lab, you will learn how to do experimental techniques and make careful observations. Before we begin, let me just give you a pre-lab discussion about this particular experiment. When we talk about matter, we can classify matter in terms of the universe. The universe has two main parts in terms of the physical science. The first is matter, and the second is energy. These two are what makes the universe in terms of the physical science. These two are related by Einstein's famous equation E equals mc squared, which we will cover in nuclear chemistry. Matter can be further classified into heterogeneous mixtures and homogeneous systems. Heterogeneous mixtures are mixtures in which you have two or more components that are not uniform throughout. An example of a heterogeneous mixture is water and sand. In this particular mixture, the consistency of the water and the sand are not even throughout. If you sample a mixture of water and sand, at the bottom, most of it's going to be sand, and if you sample that particular mixture on top, most of it will be water. Other examples are oil and vinegar, different shavings of metals with sand and leaves. All of that have consistencies that are not even. On the other hand, homogeneous systems are one in which the consistency is the same. If you sample one part of that mixture, so let's say the bottom and the top, the ratio of the mixture is the same. An example might be salt water, or brass, or 14-karat gold. All of those contain more than one component that are mixed, but the ratio of each of those components are the same throughout that particular mixture. The homogeneous can be broken up into homogeneous mixture and pure substances. Homogeneous mixtures, again, are two or more substances that are mixed together and are uniform throughout. Pure substances, on the other hand, are chemicals that are pure in terms of the substance which makes it up. An example might be sodium chloride, which is nothing more than salt, water, or let's say we have carbon. All of these are pure substances because there's only one unique chemical for each one of these. Now, we can break down pure substances into two categories. The first is going to be compounds, and compounds are chemicals in which you have two or more different elements in that particular chemical. For example, you have sodium chloride. Sodium chloride or table salt has sodium and chloride. Another example is water. that particular chemical has hydrogen and oxygen. Another chemical might be ethanol. That particular chemical has carbon, hydrogen, and oxygen. Each one of these are pure substances, but more specifically, they are compounds. And then we can also classify pure substances in terms of elements. Example might be gold, silver, carbon, oxygen, hydrogen, chlorine. You notice that for these particular substances, there's only one unique element. Now, when you think about gold, you think of gold jewelry. And gold jewelry is really not pure gold. And the reason why it's not pure gold is because it would be too soft and malleable if you had pure gold as jewelry. What jewelers do with gold is they mix it up as an amalgam of silver and other metals to harden it. So if you have 12 karat gold, what you have is 50% gold and 50% other material. If you have 18 karat gold, then that's more gold than other material, but 24 karat gold really is the pure gold material. Carbon can be found in three ways. It could be found as a graphite, or diamond, or fullerenes. That's the hexagonal buckyball carbon allotrope. Oxygen, hydrogen, chlorine, those are gases at room temperature. And you notice I put O2, and that's because as found in nature, these particular chemicals exist as diatomic. Other elements that exist as diatomic are nitrogen, fluorine, bromine, and iodine. Whenever you say hydrogen and you don't say hydrogen the element, then you're really talking about H2. When you're talking about oxygen and not oxygen the element, you're really talking about O2. So pay attention to these elements right here because they exist as diatomic. Those are the only elements that you need to worry about. So we just finished talking about the classification of matter. Again, let me summarize. Matter can be classified as heterogeneous or homogeneous. Heterogeneous mixtures are mixtures in which the system is not uniform throughout, the consistency is not even. Homogeneous can be classified under homogeneous mixtures or pure substances. Homogeneous mixtures contain more than one substance, say H2O and NaCl, which is nothing more than salt water. And if you look at the consistency, it's evenly distributed throughout. If you look at sodium chloride and water, it doesn't seem like you have more than one component in there. That's what we mean by homogeneous. Pure substances can be classified under compounds and elements. Compounds are chemicals that have two or more different elements in them. Chemicals that have only one unique element in them. And then of course, all matter consists of atoms, and atoms are the building block of matter. And atoms consist of atoms consist of electrons, protons, and neutrons, which you guys should be covering in chapter 4.